All right, today we're going to do lesson 10.8. We've got one more lesson on factoring, one more way to factor. But before we get into that, I want us to look at GCFs, all right? Finding the greatest common factor. Now, the good news is we've already been doing this for the last few days with our last couple lessons. All right, but we're really going to focus on it today. Now, we already should know that if the leading coefficient is something other than 1, we're supposed to be checking for a GCF. So I want everybody to look at letter A, and somebody raise your hand and tell me what is the GCF that we can pull out. Javion? 7. All right, now I completely agree with him. But something that we haven't done yet, so something that's a little bit new for you today, is looking to see if there is a variable GCF. Now, how do you know you have a variable GCF? If there is a variable in every single term, then we are going to pull that variable out as a GCF. So which Peyton variable shows up in both of our terms? X. Now, we've got to decide what power this X is going to be raised to. So it's going to be a little bit confusing because we're looking for the greatest common factor, but when you're pulling out a variable, you're actually going to pull out the smallest exponent that you have. So read, what is the smallest exponent that we have in this particular problem? So we are pulling out an x squared. Why? Because each term has at least 2 x's. Does that make sense? The first term is x to the third, which means there are 3 x's. So are there 2 x's to pull out? Yes. All right. The second term only has 2 x's. So can I pull out those 2 x's? Yes. I can't pull out a 3 as my exponent because the second term doesn't have that many x's in it. So all of that to say, when you're pulling a variable GCF out, you're going to pull the smallest exponent out with it. Now, just like normal, we're going to divide each term by the GCF. So what is 14 divided by 7? 2. But what is x cubed divided by x squared? And this will require going back into your memory. All right, x, because when we divide powers that have the same base, we're supposed to subtract the exponents. So x cubed divided by x squared is absolutely x. All right, what's negative 21 divided by 7? Negative 3. What is x squared divided by x squared? It's not 0. It's equal to, I heard it, 1. Anything over itself is equal to 1. So x squared divided by x squared is 1. And since we already have a 3, okay, really we're doing 3 times 1, which is 3. All right, so we're left with our final answer of 7x squared times 2x minus 3. Okay, any questions? All right, letter B. Alana, what's our GCF for letter B? 11. No x this time? We're not pulling out an x this time. Why not? Very good. The second term does not have an x in it, so I cannot pull out an x. All right, so Alana, when you divide, what do you get? 1 what? Good. So x and negative 22 divided by 11? Negative 2. And there's our final answer. Letter C. Ian, what is the GCF for letter C? 9. All right, 9 does not, 9 goes into 18, but does 9 go into 6 and 12? We got to find a number that goes into all 3 terms. 3. All right, is that the biggest number? Now, here's what you want to do, okay? This is just a trick. When you're looking for a GCF, I would always start with the smallest number that you have and see if that one works. So 3 is not incorrect. Okay, it is a common factor, but 6 is the greatest common factor. Ian, are we pulling out an x this time? No, because we only have an x squared, an x, and this term has no x in it. So there will be no x coming out. So Ian, when I divide 6x squared divided by 6, what do I get?
1.
You can put the 1 if you want, but it's x to what power? Good. My x doesn't change. I'm just dividing 6 by 6. So x squared, keep going. Is it minus?
Plus.
Okay. Plus what? 2x.
Plus 3.
There you go. Very good. So we divide every single term by the GCF, and our final answer is 6 times x squared plus 2x plus 3. All right, any questions on pulling out the GCF? Javion.
So like, say if you don't like find the greatest common factor, but you find out like multiple, would it be wrong or just equal? Like,
Yeah, you would divide, and you would look at your answer in parentheses, and you'd realize you have to reduce. You'd have to pull out another. Yeah, it wouldn't be. You would realize it wasn't the greatest common factor that you pulled out. You pulled out a common factor, but not the greatest common factor. Okay, so at that point you'd erase and you'd start over. Okay, all right, Gavin.
If it was like 6x, if it was like that problem, but at the end it had 18y squared, would we still like?
You'd have to have the same variable in all three terms in order to pull out a GCF. Okay, all right. Anybody else? Great. Let's look at example number 2. Now this says factor the expression completely. So obviously these leading coefficients are not 1 in letter A and letter B. So we are going to start by pulling out a GCF. So Tatiana, in letter A, what would you say the GCF is?
4.
All right, 4. Is that all? Okay, 4x to what power?
Second.
Is second? All right, very good. My lowest exponent in this problem is x to the first. So that means I'm only pulling out an x to the first. So Tatiana, when you divide each term by 4x, what are you left with?
X to the third.
Hold on. You did 4x cubed divided by 4x. So you pulled one of those x's out.
So I don't need anything.
Well, it was x to the third divided by x to the first.
So x squared
Okay, so x squared. Good. All right, keep going.
plus 5x plus 6x.
Do you have an x in that last one? All right, let's look at it. First of all, 20x squared divided by 4x. You did x squared divided by x to the first, and you were left with an x. But what happens in this last one? It's x to the first divided by x to the first.
Oh, I don't need one.
So you don't need an x anymore. There's no x's. So it's just plus 6. All right, awesome. Now, once we've pulled out the GCF, we are going to look inside the parentheses and see if what's inside the parentheses can be factored down anymore. Now, how are you going to know if it can be factored down anymore? Well, there's 2 ways. First of all, if it is a trinomial, that's in standard form. So x squared, x, and a constant. Or if you have a difference of squares inside your parentheses. So a binomial, that's a subtraction problem, and both terms are perfect squares. If it doesn't fit either of those criteria, then you're done. All right, but look at what's left in parentheses. We have x squared plus 5x plus 6. Is that a trinomial that could possibly be factored? Yes. So we are going to go back to our x method, because is it a perfect square trinomial? Is my first term and my third term, are they perfect squares? No. Okay, x squared is, but 6 is not. So we're going to go back to our x method. All right, Reed. Will my signs be the same or will they be different? Good. The second sign is positive, and they both will be positive because my first sign is positive. So plus and plus. All right. Gavin Downing, what number is going at the top of my x?
The 6.
Nope.
Or the 1. Or the 5.
The 5. The coefficient of x goes at the top, and what goes at the bottom?
Of the 6.
The constant goes at the bottom. All right. Now, I need factors of what, Michelle? That added give me what? So do I have a set of factors? If 1 times 6 and 2 times 3 both give me 6, is there a set of factors that I can add and get 5? 2 and 3. Awesome. So a 2 and a 3. Now, my final answer has to have my GCF, so I'm going to go ahead and pull that down. And then what are my two sets, Caleb, of parentheses, my two binomials? What are they going to be? X plus 2 and x plus 3. Now, one more time, check all of your parentheses. Can anything be factored even lower? No. So this is my final answer. Any questions? All right. Take a minute, work letter B. All right, Isaiah, do I have a GCF in letter B?
5.
All right, is it just 5?
Yes.
Okay, does anyone disagree with that? Javion?
I got 5x squared.
All right. Isaiah, do you see how both terms have an x in them? So we can pull out a variable GCF. And you are correct, Javion, 2 is the smaller exponent, so x squared is what we're going to pull out. All right, so when we divide, Javion, what did you get when you divided each term by 5x squared?
I got 9x squared. And I got minus 4x.
Okay, you got minus 4x or just minus 4? Just 4. Very good. Again, x squared divided by x squared is just 1. All right, so we look at what's in parentheses. Jacory, can 9x squared minus 4 be factored any lower?
Wait.
9x squared minus 4, can it be factored any lower? All right, he says no. Does anybody else say yes? Remember our criteria. Is it a trinomial?
No.
Is it a difference of squares?
It's a difference.
It's a binomial. That's a subtraction problem. And when I look at both terms, they're perfect squares. So it absolutely can be factored further. So we're going to bring down our GCF, our 5x squared. And when we factor a difference of squares, how many parentheses do we end up with? 2. Our signs are going to be different. And how do I find out my terms? Michelle, the square root. Now let's talk about this for a second. Addition and what operation undo each other? Addition and subtraction undo each other. Multiplication and division undo each other. So something that's squared can be undone by the square root. So that's how we take, if these are perfect squares, we're going to take the square root of both of them to get our terms. So what is the square root of 9x squared? 3x. And each set of parentheses gets a 3x. And then what's the square root of 4? 2. So each set of parentheses gets a 2. Now, can 3x plus 2 or 3x minus 2, can those be factored down anymore?
No.
No. All right, so this is our final answer. Great job. Any questions? All right, now let's look at our last type of factoring. All right, grouping only works, and this is very, very important. If we are trying to factor by grouping, it only works when there are 4 terms. So that means I cannot factor by grouping with a binomial. I cannot factor by grouping with a trinomial. I can't even factor by grouping with a polynomial that has 5, 6, 7, 8 terms. Okay? I can only factor by grouping when there are 4 terms. All right? Everybody with me? So here's how we do it. We're going to group the first 2 terms together in a set of parentheses, and then we're going to group the second 2 terms together. We're then going to pull the GCF out of each set of parentheses. So we're going to have 2 sets of parentheses. We're going to look at each separately, and we're going to pull out the GCF. Lastly, the matching part will become 1 set of parentheses in our final answer, and the GCFs will become the other set of parentheses. Now, let me show you what that means. First of all, when you look at example 3, do you think it's important when we're going to factor by grouping that our problem is in descending order or standard form? Yes. Okay, so looking at A and B, let's go ahead and look at them both. Are they both in standard form? Yes. All right. Do they both have 4 terms?
Yes.
Okay, then we know that factor by grouping is actually going to work. So here's what it looks like. We're going to take the first 2 terms and we're going to put them in a set of parentheses together. So x cubed plus 2x squared. We're then going to group the second two terms. So 3x plus 6, we're going to group them together in a set of parentheses. We're then going to look at each set of parentheses separately. So read, if you're looking at the first set of parentheses, what is the GCF that's going to come out?
1.
All right, 1, which we don't have to put because is there a variable GCF? Okay, x to what power?
7.
Very good. So he can put 1x squared if he wants to, but since we have that x squared, we don't have to put the 1. All right, why x squared? Because the first term had x cubed, the second term had x squared, so we pull out the smaller exponent. So read, when I divide each term by x squared, what am I left with?
X to just X. Plus.
There we go. X cubed divided by x squared is x to the first. 2x squared divided by x squared is just 2. All right. Gavin Cameron, what's the GCF that we would pull out of the second set of parentheses? 3. No variable this time? No. Very good. So when we divide each of those terms by 3, what do we get?
1x. And 2
Plus or minus?
plus.
Plus 2. Now remember the last statement? Go back and look at it for a second. The last statement said that the matching part will become one set of parentheses. The GCFs will become the second set of parentheses. Do you see a matching part in this problem? Yes. All right. When you pull those GCFs out, those parentheses should match every single time. If they don't, you know you've done something wrong. So if that had been x plus 2 and then like x plus 3, you would need to go back because something is wrong. The parentheses should always match once you've pulled out the GCF. So in your final answer, the first set of parentheses is going to be x plus 2. The matching part becomes one set of parentheses. The second set of parentheses is going to be your GCFs. So Peyton, what are the GCFs that we pulled out in this problem? X squared plus 3. So do you see the matching piece becomes one set of parentheses in your answer? The GCFs become the other. Now check, can either of those be factored any further? What can be factored further? All right, x squared plus 3 might make you think, but it's not a difference of squares. All right, so this is as far as we can go, but that is your final answer. Any questions? All right, take a minute and work letter B. All right, Peyton, how did you start this problem? What did you do first?
I grouped them.
All right, what did you group together first?
X cubed and 2x squared.
All right, and what did you group together in the second set?
Negative 36x and 72 negative.
All right, what was the GCF you pulled out of the first set of parentheses?
X something. X2.
Very good. Always pull out the smaller exponent. So what did that leave you with inside?
X plus 2.
Awesome.
Or no, regular.
Oh,
I didn't say it.
just 2.
You're in it.
Remember, x squared divided by x squared is just going to be 1, so we just bring down the 2. All right, Jordan, what's the GCF you pulled out of the second set of parentheses? Now remember, when you're looking for a GCF, I would always start with the smaller of your numbers or the smallest of your numbers and see if that works. So in this set of parentheses, the smaller number is negative 36. So is 72 divisible by negative 36? Yes. So negative 36 is going to be the GCF that we pull out. Why negative? Because we do not want a leading coefficient that is a negative number. So inside the parentheses, the leading coefficient was a negative 36. So we're pulling out a negative 36. Because Jordan, what does that leave me with? When I divide everything by that negative 36, what am I left with? All right, is it minus 2 or plus? Because remember, it's a negative 72 divided by a negative 36. That's a plus. Good. And because my two parentheses match, I know I'm in good shape. All right, my final answer. Kayla, what's the first set of parentheses in my answer? Good. That matching part becomes one set of parentheses. Kayla, what's the other set going to be?
X squared minus 36.
Good. Now, before I box this in, I'm going to check. Can either of those binomials be simplified or factored anymore?
No, ma'am.
I hear yes and I hear no. Who said yes? Ian, what can be factored more?
I didn't say yes, but I just raised my hand.
All right, what can be factored more? Of those two, which one could we factor some more? Ian, I'm asking you.
Negative 36.
Well, that's not the whole thing I'm going to factor. What's the whole thing? What's the whole binomial? Somebody help him. What's the whole binomial?
X squared minus negative.
All right.
36.
Now, somebody raise your hand and tell me why I know that that can factor more. Peyton.
Square root, sister.
But what's it called?
Square root.
That's a different something. Different space.
It's the difference something. It's the difference of two squares. That is how we know. Now, Peyton, you were trying to tell me it was a perfect square trinomial, but it's not a trinomial, right? Because it only has two terms. So when I have two terms, it's a subtraction problem and both terms are perfect squares. It's the difference of two squares. So go ahead and bring down that first set of parentheses because that won't change, the x plus 2. And then we know the difference of two squares has how many parentheses? 2. My signs are going to be different. Good. And Alana, what's my first term going to be? X. The square root of x squared is x, so each parenthesis gets an x. And what's my second term going to be, Alana? Because the square root of 36 is 6, so each parenthesis gets a 6. Can any of them be factored any more?
No, ma'am.
No, so this is my final answer. So that is factoring by grouping. Are there any questions? All right, that is lesson 10.8.